more thing about trapezoids that we need to know, and it has to do with what's called a mid-segment of a trapezoid. Here's my definition. The mid-segment of a trapezoid connects the midpoints of the legs. So that's just the definition, right? So you can see, okay, AE is congruent to ED, BF is congruent to FC. That's just the definition. So we call EF the mid-segment. And it has some important properties, just like the mid-segment of a triangle, if you remember from a long time ago. Mid-segment of a triangle connects the midpoints of the sides, and what's important about it is that it was parallel to the base, and that's the same thing in this case. So the mid-segment of this triangle, EF, is parallel to both bases AB and DC, right? Because trapezoids have two bases. This is a base, and this is my mid-segment. So all three lines are parallel if EF is a mid-segment. In addition to that very important fact, just like with the mid-segment of a triangle, it was this distance here, right? The mid-segment was 1/2 of the base, or the third side, okay? So in a similar sense, it's 1/2 of the bases added together. So we say EF is the average of the bases, or 1/2 of AB plus DC. I'm going to put in parentheses the mid segment is the average of the two bases. Okay, if you remember, average is adding and then dividing by however many there are. So how do we apply that into solving equations? Look at number 2. We're using the same picture up here, so I'm just going to kind of clear it. If AB is 7, DC is 31, find EF. So we use this formula, right? EF is 1/2 of 7 plus 31. Ta-da! And then we just solve. So 1/2 of 38. So EF is 19. Make sense? Great. Now, number 4 is a little different, so let's all make sure we understand number 4. If AB is 41 and EF is 47, oh, interesting, find DC. So I'm still going to use the same formula. What's different, though, is I know the mid-segment is 47. So I plug that in for EF, and that's 1/2 of 41 plus, I don't know, plus DC, because that's what I'm trying to find. Yes? Does that make sense? And then from here, you're just working backwards. So what I like to usually do is get rid of this 1/2. Instead of distributing it, because you'd have to distribute like that, I'm going to multiply both sides by 2. When I multiply the right by 2, it cancels that fraction away. But whatever I do to one side, I have to do to the other, right? So that's going to become 94 equals, and then I'm left with 41 plus DC, because the 2 and the 1/2 canceled out, right? Okay. And so all that's left is to do 94 minus 41. So DC is 53. I subtracted 41. So that's a working backwards type of problem. Yay. Alright, let me skip to number 6, because like I said, I'm doing the evens. So for this trapezoid, L and M are midpoints of the legs. That tells me LM is a mid-segment. Find KJ. So obviously I know I'm going to have to find X first, setting up with the formula. So the mid-segment, in general, here's my formula. Mid-segment is equal to 1/2 of base 1 plus base 2, right? The average of the bases. So the mid-segment here is 25. One of the bases is 2x plus 11, and the other base is 6x minus 1. And then solve. So start by simplifying what you can. So in this parentheses, you have 8x, and then you have this 11 minus 1, so that would become plus 10. Bring everything else down. So again, you can distribute the 1/2 by dividing the 8 and the 10 by 2, or you can multiply both sides by 2, which is what I like to do. Doesn't matter. So I get 50 equals 8x plus 10, because I canceled out the 2 and the 1/2. I subtract 10 from both sides to get 40 equals 8x. Divide both sides by 8. So x is equal to 5. Oh, we're not done. So kj is going to be 6x minus 1. So we just plug in 6 times 5 minus 1. So 30 minus 1 is 29. All right. I'm going to pause this now because if it gets too long, I can't upload it. So I'll post another video going over the properties and those examples as well. Cool.